Hello and welcome. In this video, we will talk about few more examples on DFA. Design DFA over alphabet set sigma is equal to a comma b such that it accepts strings which start with a. So all string must start with a. After that, it can follow anything. So language for that would be first letter A, then there would be A or B, double A, AB, BA, BB, then triple A, any combination of A and B after that. A is a part of language, so from initial state, when we read first A, it should go to the final state. We cannot read B from Q0 because string cannot start with B, so if we'll read B, it will go to the dead state. From Q1, we can read any combination of A and B, so we can have a self loop of A and B. So through that, we can generate remaining all the characters in string. And as I said, if we read B from Q0, it will move to the dead state. So this is the desired DFA. Design DFA over alphabet is equal to alphabet sigma is equal to a comma b such that it accepts the strings which ends with a. So last letter should be a. So language contains a, then double A, BA, double AB, etc. So here at the end it should be a. Before it could be any combination of a and b. But as single A is a part of language, when we read the first A, it should go to the final state. We can read any number of A's from Q1, but we cannot read B and remain in same state. Right? So let us now try to put all the appropriate arcs. From Q0, arc of A is already out. We have to adjust the arc of B. So can we put it as a self loop? Yes, obviously. If we read 1B, 2B, 3B or any number of B, to terminate we must have to read 1A, then only that string would be accepted. From Q1, we can have arc of A as a self loop because those all strings will end with A only. So we can read first A, then second A, third A, fourth A, any number of A, but that will ensure that whatever strings are accepted, that will be ending with A only, and we cannot have a self loop of B on Q1. Otherwise, string will end with B as well. So we have to adjust the arc of B from Q1 to Q0. So this will generate all possible or all valid strings which are in language L. Design DFA over sigma is equal to a comma b that accepts strings which contains A. Now A could be at the beginning, at the end, at the middle, any position A could remain present, but A must be in the string. So the L would be for that A, double A, AB, BA, triple A, AAB. So here A is in center as well. It can remain on any position. So Q0, when we read first A, it should go to the final state. So this string contains A. Now before this A we can read anything, after this A we can read anything. So this is after anything. After reading A, if we put self loop of A comma B on Q1, it will generate any combination of A and B. From Q0, we have to generate the arc of B. A is already out. So can we have self loop on Q0 for B? Obviously, because it will generate all valid string. Even after reading infinity number of B, we must have to read at least one A to go to the final state. So that string will definitely contain A. Construct a DFA which accepts set of all strings over alphabet sigma is equal to A comma B which starts with AB. So now string should start with AB. It can follow any combination of A and B. AB is the minimum length string. So we can have A and B like this. AB is the initial string. So after that we can read anything. So from Q2 we can have a self loop of A and B. So that will generate any combination of A and B, but it will ensure that string must start with AB. From Q0 we cannot read B because if we read B, string will start with B, which is not allowed. So it goes to the dead state. From Q1 we must have to read B. So if we read A, it is not valid. So again, it is going to the dead state. Construct a DFA which accepts the set of strings over alphabet sigma is equal to A comma B which ends with AB. So now AB must be at the end, and before that it can be any combination of A and B. So AB is the smallest length string. So let us first derive DFA for that. Now after AB, we cannot accept any string. From Q0, we can read B as a self loop. That is possible because after reading any number of B, we must have to read AB to go to the final state. So from Q0, both arcs are adjusted. From Q1, arc of B is already there. Arc of A we need to adjust. Can we have self loop of A on Q1? Obviously, that is possible Because see, if I read first A from Q0, I'm moving to Q1. After reading any number of A's from Q1 through self loop, to go to the final state, I must have to read B. That means my string will definitely end with AB. Right? From Q2, both arcs needs to be adjusted. If we read A from Q2, self loop is not possible. Otherwise, string will end with in either BA or double A. Okay? Even I cannot have a self loop of B. Otherwise, string might end with B, which is not allowed. So self loop of A and B are not possible. Let us try to adjust it for the nearest neighbor. Can we have arc of B from Q2 to Q1? That's very much possible, because when we read A, then to go to the final state, I must have to read B again. So from Q2, I'm reading A going to Q1. From Q1, I'm reading B going to Q2. So that string will definitely end with AB. So that is valid. Can we have the arc from Q2 to Q1 on input B? That won't be allowed, because from Q2 to Q1, if I move by reading B, then from Q1 to Q2, I can move by reading B. So there will be 2B at the end, and string is accepted, which is not part of language, because string must end with AB. So that arc is not possible. So only possibility is that we need to add arc from Q2 to Q0 for input B. Construct a DFA which contains strings over alphabet A, B that is having AB as a substring. So all the strings must have AB as a part of the language. So L is equal to AB. Now AB can be at the beginning, it can be at the end, it can be anywhere in between, but AB must remain present. AB is the smallest length string, so let us first draw DFA for that. So this is the DFA for AB. Now we will try to adjust all possible arcs. From Q2, we can have a self loop of AB, because after AB we can read anything. So this is the best possible way we can do. Now from remaining two states, we will adjust the arc so that we can have AB as a part of the strings. From Q0, can we have self loop of B? Yes, it is very much possible. Even after reading any number of B's, to go to the final state, we must have to read AB. From Q1, arc of B is already out. Can we have self loop of A on Q1? Yeah, that is also very much allowed, because after reading any number of A from Q1, to go to the final state, we must have to read B. So AB will be definitely part of any string which is generated by this DFA. Design DFA over AB that accepts strings having ABBA as a substring. So ABBA must be present. Before that, there could be any combination of A and B, and after that also there could be any combination of A and B. So let us first design DFA for the smallest length string, which is ABBA. This should be accepted. Right? Now from different states, we will adjust the arc. From Q0, can we have self loop of B? Yes, it is possible, because after reading any number of B, to go to the final state, we must have to read ABBA. From Q1, arc of B is already out. Can we have self loop of A on Q1? That is also possible, because if I read first A from Q0 to Q1, and after that even I am reading 10 A's from Q1 using self loop, to terminate, I must have to read BBA after that. So string is definitely having ABBA as a part of it. From Q2, arc of B is there, arc of A we have to add. Can we have self loop of A on Q2? Obviously not, because if we do that, then our string from Q0 could be A, then B, then A, then B, then A. So which is not containing ABBA. Okay? So we cannot have a self loop of A. Can we have arc from Q2 to Q1 for input A? Yes, it is very much possible, because after reading Q2, if we read A, then we are going back to Q1. And to move to the final state, we must have to read again BBA. So that string will definitely have ABBA as a part of it. Similarly, from Q3, we cannot have self loop of B. Otherwise, string might have multiple B's, more than 2 B's and then A. That will not contain ABBA string as a part. We cannot have a self loop. We cannot have an arc from Q3 to Q2 as well on B, because again, there would be same problem. We can have a 1B from Q1 to Q2, second B from Q2 to Q3, third B from Q3 to Q2, fourth B from Q2 to Q3, and we are reading A and we are going to final state. So it doesn't contain ABBA substring. Right? So same we have to do from Q3. If we read B, then it is going to Q0. Right? Because if we move to Q1, then also there will be a similar problem. And from Q4, we can read any combination of A and B because A, B, B, A, we have already read out when we are in state Q4. So after this A double B A, we can read anything. So we can simply put self loop of that on Q4. So this is what the desired DFA. L is equal to strings that do not having ABB as a substring. So what we'll do is we will first design the complement of that. That means we will design DFA that accepts string having ABB as a substring, because it is always easier to draw a DFA having a pattern than not having the particular pattern. So our goal is to design DFA which do not have ABB as a substring. So first we'll draw the complement of that. That means having ABB as a substring. So that is pretty straightforward. ABB is there, then it is accepted. Now we just need to adjust the arc. From Q0, we can have a self loop of B, because after reading any number of B, we must have to read ABB to go to the Q3 state. From Q1, I can have a self loop of A as well. So I can read any number of A from Q1, and to go to Q3, we must have to read BB. So again, ABB will be definitely there. From Q2, we cannot have self loop of A. Otherwise, the pattern ABB may not be maintained. We can read 1B from Q1, then we are going to Q2. From Q2, we are reading A and remaining on same state, and then we are reading B. So that will have BAB pattern. So ABB is not there, right? So that loop is not possible, but we can always have an arc from Q2 to Q1 on A. So once we read A from Q2, we are moving to Q1, and to go to the final state, we have to read double B. So ABB is ensured. From Q3, we can read any combination of A and B, because after ABB there can be any combination of A and B. So this is the desired DFA. We have tested all the possible arcs from all the states. To construct DFA which is not having ABB, we just have to take the complement of this DFA. So what we need to do is simply change all final states to non-final states and all non-final states to final states. And that will give you the complemented language. So that is pretty straightforward. When you think that you cannot design DFA for the pattern not having something, you can always derive it for having that pattern. And then you simply complement the states. Make your final states to non-final states and non-final states to final states. So this DFA will give you the strings which is not having ABB as a part of it. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.